Hi, this is your Professor Sudha Kolathu Parambil, section 11.4, hypothesis test for two population standard deviation. So, in this section, you are going to learn how to find the critical values of the F distribution and perform the hypothesis test for two population standard deviation. The test for two standard deviation is sensitive to the assumption of normality. So if the population differ even slightly from the normal, this test should not be used. First, look at the notation and assumptions. Sigma 1 and sigma 2 denote the standard deviation for two populations, and S1 and S2 denote the sample standard deviation, N1 and N2 the sample sizes. And this method requires the following assumptions. We have an independent random sample from two populations and both the populations are normal. When H0 is true, we can sigma 1 equals sigma 2. So the null hypothesis is sigma 1 equals sigma 2. And the alternate hypothesis can be sigma 1 less than sigma 2, this one, or greater than or not equal. The test statistic for this type of test is denoted by this capital letter F, and we can calculate that by divide the largest sample variance by the smaller sample variance. When the null hypothesis is true, sigma 1 will be equal sigma 2. Then the sample standard deviation S1 and S2 also will be of the same size. Then the test statistics will be close to 1. So if the test statistic is much greater than 1, we will reject the null hypothesis. So in order to use F as a test statistic, we must know its distribution when the null hypothesis is true. And this distribution is called an F distribution. F distribution is the ratio of two variants. And F distribution has two values for degrees of freedom. So two values for the degrees of freedom. One is associated with the numerator and one will be associated with the denominator. And F distribution is skewed to the right. Since F distribution has 2 degrees of freedom, we usually represent that by like two numbers with a comma. So 3 and 16 represent the degrees of freedom, and here 3 associate with the degrees of freedom of the numerator, and 16 is the degrees of freedom with the freedom for the denominator. And critical value of the F distribution we can represent by like F alpha. That's the area in the tail to the right of the critical value is alpha. And remember, the value of the test statistic will be never less than 1. So we do not need to find the critical values for the left tails. Because the test statistic is the quotient of the larger sample variance by the smaller sample variance, and it's never less than 1. And we can find the F distribution from table A5. Now let's see how to find the critical value. Alpha equal 0.05 for F 3, 16 distribution. So we will use table A5 to do this problem. From table A5 for the F distribution, find the column corresponding to 3 degrees of freedom for the numerator and the row corresponding to 16 degrees of freedom for the denominator. So 3 is for column and this is for the row. But while choosing the row, we can see there are a lot of values of 16. So we need to choose which one we should choose. So look at the area, alpha equal 0.05. So this is the area correspond to that. So this is the degrees of freedom in the row, and this is the area, and find the intersection of the column with degrees of freedom 3 and the row with degrees of freedom 16 with the area 0.05. That intersection is 3.24. So we can conclude this answer. Critical value is f 0.05 equal 3.24. And this diagram shows the probability density curve of F316 distribution. So right now you learn how to find the critical value of an F distribution. Now let's see how to perform a hypothesis test for two population standard deviation. First, I'll describe how to perform a hypothesis test using the critical value method and table A5. Then I'll describe how to use p-value method with technology. Because we compute the test statistic by dividing the larger sample variance by the smaller sample variance, and the value of the test statistic is never less than 1. Therefore, the test statistic cannot fall into the left tail of the distribution. The critical region for the one tail test is always like f greater than or equal f of alpha, and for two tail test it will be the critical region will be the area of alpha over 2 on both left and right tail. And since the test statistic never falls into the left tail, we reject the null hypothesis if f is greater than or equal f of alpha over 2. Now let's look at the procedure for performing the hypothesis test for two standard deviation. First, state the null and alternate hypothesis. Then choose a significant level alpha and find the critical values. If it is one tail, critical value will be f of alpha, and if it is two tail, it will be f of alpha over 2. And compute the test statistic. This is the same formula I explained before. Okay. And we reject the null hypothesis. And for both the one tail and two tail test, we reject the null hypothesis if the test statistic is greater than the critical value. And now state a conclusion. So let's look at an example. So in this example, in a series of experiments to determine the absorption rate of certain pesticide to skin, two pesticides were applied to several skin types, and the variance of the amount absorbed in the skin for pesticide 1 and pesticides 2 are given. So these are the values. And pesticide 1, there are 6 specimens, and pesticide 2, 10 specimens. We need to conclude that the standard deviation of the amount absorbed is greater for pesticide 1 than for the pesticide 2. Here we need to perform the hypothesis test for two population standard deviations. So we know that this is we need to apply the F test. So for F test, the population should be normal. So in the problem it is given that assume that for each pesticide the amount absorbed are a simple random sample from a normal population. So the assumption are satisfied, so we can proceed. So first state the null and alternate hypothesis. So standard deviation of pesticide 1 is greater than pesticide 2, that is the alternate hypothesis. And step 2, significant level alpha equal 0.05. Step 3, we need to find the critical value. So degrees of freedom of the numerator, that is 5, and for the denominator that is 10 specimens, so 10 minus 1, that is 9 degrees of freedom. So from the table, this is a right tail test, right? Okay, right tail test. And from the table, find f of 0.05. So on the table A5, look at column, that is 5, and with a row 9 with area 0.05, and we will see that this is the critical value, that is equal 3.48. So I find the critical value by looking at the column with degrees of freedom 5 and the row with degrees of freedom 9 with the area 0.05. So I got f of 0.05 equal 3.48. That is the critical value. Now find the test statistic. So test statistic f is the largest sample variance and the smaller sample variance, that is 0.6, so 3.83. So this is the test statistic f. Now step 4, determine whether to reject the null hypothesis or not. So we will check whether f is greater than f 0.05. So capital letter F is 3.83, which is actually greater than 3.48, right? So we reject the null hypothesis at alpha equal 0.05 level. Now state a conclusion. We conclude that the standard deviation of the amount observed is greater for pesticide 1 than for pesticide 2. We now perform the test for 2 population standard deviation using the p-value method. We calculate the p-value using the calculator. So variance of each pesticide is given in the problem. Now take the square root of each one, and in the calculator, TI-84 calculator, press stat, then test, then option E, that is to sample F test. Then you will get the screen like that and enter this value. If you want, you can directly enter this value as square root of 2.3. I just showed you this so that you will know that where these values are coming from. So you can directly enter square root of 2.3 and square root of 0.6 here itself. And since we are checking sigma 1 greater than sigma 2, so highlight that option, then press enter. So first press stat, test, option E, to sample F test, press enter, and input stats S1, that is the standard deviation, so square root of 2.3, and N1 is 6, then square root of 0.6, then N1 is 10, or N2 is 10, Then we are checking whether sigma 1 greater than sigma 2. So highlight that. So press enter. Then select calculate. Press enter again. So you will get the p value. So p value is 0.038 so if you round it to 3 decimal places, it is 0.39, which is less than alpha. So we reject the null hypothesis at alpha equal 0.05 level. So in this section, you learn how to find the critical values of the F distribution and how to perform the hypothesis test for two population standard deviations.